In this case, this quark number is defined like this way, actually, this petrolatum charges. Well, I can do the same thing with this renormalizable terms, actually. So in this kind of non-normalizable operator is obtained in terms of renormalizable term. Now, we question whether this action can have really exact global symmetry except anomaly terms. That's possible with model-independent action. So model-independent action, people say written, but actually it is written by Green and Schwartz. So I call Green, Schwartz written model-independent action. So I worked this with Kim2, so I show him here. So many years back, I considered this model-independent action again. Why? Well, there are antisymmetric tensor in heterotic string. This is a BMN. And all actions, model-independent action and model-dependent action are the field in BMN. And we calculated the coupling decay constant of model-independent action long time ago. This is of order of 10 to 15 to 16. FA is 10 to 15 to 16. It's a very simple calculation. And this is, I summarized invisible action couplings before explaining superstring actions. So somehow nobody calculated this invisible action couplings. I find only I calculate these invisible actions. This is needed to detect at action laboratories. This is CA gamma gamma action photon photon coupling. Depending on the charges of the heavy quark, we obtain this one, and DFSG we obtain this one, and I cited this. So this one. So in superstring action, so I explain this what does it mean, what this means. If anomalous U1 is exact except the gluon anomaly, then it is 2/3. This is the one. But as we said, these superpotential terms can break the petrolatum symmetry. In that case, we can consider approximate petrolatum symmetry, in which case you have to be careful such that up to dimension 7, dimension 8 operators, all these terms are forbidden. Then we can consider approximate U1 petrolatum symmetry for the strong CP solution. If some terms stronger than dimension 7 operators are present, you do not succeed strong CP solution. So there can be approximate U1 petrolatum symmetry, but the best thing is exact petrolatum symmetry such that no superpotential term breaks U1 symmetry. That is anomalous U1. What is anomalous U1? So in that case, this coupling is greater than 2. So this summarizes the current search, action searches, action photon-photon coupling, and this is anomalous one. So this region is allowed if U1 anomalous is approximate, not exact. If U1 anomalous is exact, this one, anomaly. U1 anomalous is that all this part is forbidden. So most probable, very attractive, string invisible action forbid all these terms. Only this part is allowed. 5 minutes. This one is actually model-independent action. Model-independent action doesn't have U1 anomaly, so this is no anomaly. Well, how U1 anomaly appears? When you consider EA cross EA prime heterotic string compactification, there can be many U1s, many U1s. Some of U1 combination can have anomaly. So this, from the gauge sector, there is an anomaly. Also, there is a B mu nu term, that is model independent of action. In that case, this B mu nu combined to this U1 anomalous gauge version from E8 prime, and it gives mass to this gauge version. Then below the scale, there survives global symmetry. That is what we want to interpret as invisible action. So that is what we mean. It doesn't have any gravity problem, which I mentioned from wormholes, because originally it was from gauge symmetry. So there is no problem from gravity point. Now, because Sherman says that this is CP and cosmology. So, because my title is CP, this CP works all three cases. So CP violence certainly for baryon asymmetry, for CDM, for axions, and also this is axion energy density. And, because I have my second title is not good, so I go on. I go. Type 2 leptogenous, because this is CP can interpret all these things. Dark energy is, because I explained it briefly, because in the morning we heard about what is the dark energy. So this is a real inflaton. This is high energy inflation. Maybe there are other fields which is very slow. And so this can be, if vacuum settles here, like here, then there can be dark energy. It depends on the model, how you define this global symmetry. That's essential action. So in fact, we have an explanation for this small dark energy in particle physics framework, not in terms of one inflaton field. So this I showed. There are three conditions for baryon number generation, and also C violation is needed. And because this baryon number generation by SU5 accompanies lepton number generation, and in that case, B minus L is 0, so SU5 is not working. We need a larger case. So SO10 can have B minus L violating interaction, so SO10 can work, but in usual, we do not go that gradientification, but only single neutrino. It can break B minus L. So this, I explained this one before. And so we can define, as I said, this definition of lepton number minus 2 for Higgs doublets. So however we define, it doesn't matter unless HU does not develop vacuum expectation. The upper case, defining lepton number in this way, I call type 1 leptogenesis. Defining lepton number in this way in the lower case, that I call type 2 leptogenesis. Type 1 leptogenesis. So in terms, so type 1 leptogenesis, we have this tree-level diagram plus this loop diagram. Then you look at this phase. If there's only one heavy neutrino, all these phases goes away because you calculate interference. This plus this one complex. So this goes away. So with one heavy neutrino, you cannot obtain CP violation, and there's no lepton generation. So we need lepton number and CP violation at one point. So type 2 leptogenesis we do differently. So lepton number definition is in this way. So HU. So this term violates the lepton number. So the diagram is like this one. So this term, basically this term violates lepton number, and CP violation is PMNS matrix. CP violation in this case is PMNS matrix. So this I call type 2 leptogenesis. For this to work, you know that this temperature, at high temperature, this SU2 cross-1 breaking must be manifest, because PMNS matrix must be there. So actually it is possible to have SU2 cross-1 breaking dominated at high temperature. In fact, there are such models, and we calculate this Palloran process to estimate lepton number. So just this one. I talked about CP violation may influence at all stages of the universe evolution. J is given in a simple form. So invisible action can be called dark matter. Type 2 leptogenesis use the phase of PMNS matrix. For this, we need certain CP violation models with SU2 cross-ion breaking at high temperature.
Any questions?
I skipped many times.
So invisible axiom, I know the searching is going on in Korea. So how's their results compared to the windows you still have?
Okay, so I will go back. I skipped that. After bicep 2 results, the Bicinelli and Gondolo calculated the axial mass in this way. I showed this one in my summary graph, rotated 90 degrees. So if you look at this one, this alpha D is greater than 1. So if alpha D is 100, if you consider Cambridge's calculation of string domainal creation of dark matter, then it is very large. So it is almost ruled out. So these are the numbers. So if alpha D is order 1, this is just 2, then maybe MA must be about 10 to the minus 4 times 10 to some number around 10 to the minus 4 electron volts. So at Korean laboratory, they try to detect this small mass, about a few times 10 to the minus 4 electron volt. So if you, I heard in Sydney from some Japanese group of ICR group that they calculate this string domainal generation of axioms, and their calculation is similar to Florinda estimate originally. This is of the same order. They didn't write the paper yet. Previously, people considered this one of 20. They used their calculation. 2012 calculation, they have roughly 20. But now they have order 1. So I have some transparency showing this one, but Sydney, I copied the talk by Sekiguchi. So this one is close up right. You note that this one. This one is action oscillation. One is all domain or this is the other one. That's the same group calculated this domain or generation of dark matter actions in 2012. It's the same group.
Okay, more questions? I do have one question. For the CKM matrix, you mentioned the KS parameterization.
Yeah.
I guess most audience do not know what does KS stand for.
Kim2. So, this Kobayashi-Maskawa parameterization. Kobayashi-Maskawa parameterization, that is determinant is not real, Kobayashi-Maskawa. So if you factor out overall phase, Kobayashi-Maskawa parameterization gives delta pi over 2, like us. So it is not, it depends on which parameterization you use. You use Kobayashi-Maskawa parameterization, you end up having delta equal to pi over 2. If you use Chow-Ping-Mai parameterization, you end up having 67 degrees.
Okay, if no question, let's move to the second speaker. The next speaker is Hagiwara.